Alright, in this video, I'm going to be talking about relays. Okay, so a relay is quite similar to a transistor in the fact that if you give it a little current, you can actually close an open bit of your circuit. Basically, it's a powered switch, just like a transistor. If you don't know what a transistor is, you can just watch the video I have. Okay, but the difference is that the relay operates using magnetic fields. Yeah, um, and it has a inductor inside of it. Yeah, and there are a much more. There are different use cases for relay as compared for transistors. So I'm going to go into how a relay works. You don't really need to know this, but it's good to know. Okay, so this is generally how a relay looks like. You see, we have this magnet here, right, with the coil magnet and shit we learned in like kindergarten. We have this armature here actually, which is kind of cool, and it pivots around this point here, and there is this line that is connected to this armature, and this line here and this line here are actually wires. These are wires, okay. Um, and what happens is if this armature pivots along this pivot, right? This wire will actually move along with this armature. So in what case does this armature move? So we have this magnet here, right? What happens if we, I don't know, put a small current through that magnet, through that wire? So due to the magnetic effect of current, which I realize you might not know, but okay, there is basically, right, once the current flows through this, it turns into a magnet. And at the pole here, this armature gets attracted. So what happens? It pushes this wire up, and then it connects the two wires. Okay, what I didn't say is that there's this triangle bit here. Yeah, that's conductive. That's conductive. So what happens is when this is pushed up here, current can actually flow like this. Okay, so that's generally how a relay works. One more property of relays is that they have a maximum voltage and they have a maximum current. So how to identify that is on the relay itself, you will see, like, let's say 24 volts, you see 3 amps, and those numbers should indicate to you what is the maximum input DC voltage, what is the maximum current. Okay, so what makes a relay special? Oh, okay, let's not talk about that first. Let's talk about the two different types of relays that you need to know. That is the single pole single throw relay and the single pole double throw relay. Okay, so in a single pole single throw relay, you kind of just have this relay, and you have a switch, and there's 3 lines, and that's pretty much it. And then let's say we connect it to power, right? Then okay, then the switch is closed, and then if there was like a diode or whatever, then it will close. Yeah. So that's very simple. Basically, you put power in, it closes the circuit. But then now we have this different type, single pole double throw. The difference is that in this single pole double throw, we actually have two output pins, so to speak. We have an NO pin and we have an NC pin. Alright, what does that even mean? NO and NC is an abbreviation. And NO stands for normally open, NC stands for normally closed. Okay, the pins are named as such as normally. That means if you're not putting power through here, you're not putting power, the switch is closed normally. You can see it's in the closed state for this circuit line here. But if we were to put power, then this switch is actually going to be attracted here. Okay, it doesn't touch, but imagine it touches. Then now this will be the current will flow through this instead. Yeah, so that's why it's called NONC, because this is normally open, this is normally closed. Alright, so what makes a relay special? Okay, I mean, yeah, it is a switch, but can't you just use a transistor? And I suppose yes, but the relay has a very special use. Okay, so right here, right, we have a relay circuit, and then we have the relay here, and there is V in, which is agak-agak 12 volts DC. Let's just remove the agak. It's 12 volts DC. Okay, the input. And then we have this. Okay, so this is an SPST, SD single pole SPST. Yeah. So we have an SPST relay here, and then we have this circuit, and then we see 240 volts AC. Okay. So why is a relay special? It's because in a transistor, right? Let's say we were to use a transistor for this circuit, which will look like this. It would look like this with V in here. Then we got then this would be the 240 volts AC already. Guess what, buddy? This destroys the transistor. It will destroy the transistor because it cannot stand 240 volts AC going through it. It will be ripped apart, it will explode. But here's the thing, this relay can actually be split up into the controlling part and then the output part. And realize that the controlling part never touches the output part. So 240 volts AC is very scary, very dangerous for components. But with the relay doesn't have to touch the AC at all. All it needs to do is create a magnetic field which pushes this switch down, closes it, which completes this circuit. And that's why a relay is special. The relay is special because it can deal with very, very high voltages and not harm the controlling circuit. Because again, 240 volts AC pretty much just damages any component that does not have sufficient protection. Yeah. So that's why the relay is special. One more aspect of the relay, there is this flyback diode here. This is a flyback diode, okay? Why do you need a flyback diode? Well, I think in the fundamentals video, I mean, if you don't know what it is, go and check it out. I say that as long as you have a coil, which is pretty much an inductor, when you stop putting current through that coil, it's going to release current in the opposite way that you were supplying current. And as I already said, the relay has a coil. So you need a flyback diode. That's why. Okay. And yeah, so yeah, the relay is very simple. That's why this video is short. Yeah. So that is the relay. Yeah, pretty much that's it. I have no other thoughts. So thank you for watching.